Hey there guys, Networkberg here, hope you're doing well. So in this video we will be having a little bit of a match off between two routing protocols, namely OSPF and my new personal favorite protocol, ISIS. This thing is insane. I love how scalable it is. I just love how it works. I've been spending the last 2 weeks just labbing it. Instead of creating new videos, I've just been working with ISIS because I've enjoyed it so much. I really think it's one of the coolest routing protocols that I've ever seen, and it really makes a lot of sense. It just makes you think many times when you deploy it or actually bring it online. It's like, hey, that actually makes a lot of sense. Like, why do we do it this way with OSPF? So hopefully this video also gets you as excited about ISIS as I am now. And then if you are looking to maybe bring ISIS online in your own network, maybe this will just give you some point of reference just to start, where you can begin and learn some of the key phrases like level routers and whatnot. So let's get into the video. All right, so let's get into the slide, and I'm saying ISIS, building your ISP backbone. And I use the word ISP backbone deliberately because this is mainly used by large network operators like ISPs or large cloud-based providers like CDNs, maybe even your AWSs or your Azures. They're probably having some form of ISIS running in the background because it's just that damn good. It's able to quickly reconverge the network if needed. It learns routes effectively. It has a bunch of other benefits that I'm actually going to be talking about when I do the comparisons, but ISIS is really that good and awesome for big networks. So let's just go on with the slides. Now, first thing is the ISIS and OSPF similarities, because they do work relatively the same. They are both interior gateway protocols and they're designed kind of for the same function. Just some of the things changes on how they work, but they're both IGPs. So that means we're going to use them inside our own autonomous system, inside our network. So we're not going to use this to peer with somebody or connect to a different network and learn their routes. It's not for that. It's for our network to effectively learn routes and maybe even deliver specific services. We also have link state. So there are both link state protocols, meaning they will build a link state database using certain protocols and stuff like the Dijkstra SPF algorithm in order to work out stuff like costs and then find the best cost or path to get to a specific destination and then inject that into your routing table. It also uses hello packets just to form adjacencies and do certain updates and stuff. Even though the hello packet is named a little bit differently on ISIS, it's still a hello packet. It does the same function. And then they are both, well, they have a hierarchy. So basically you might have like what you might assume to be a provider router, or a core router or a core area or a backbone. You've got your backbones and then you've got your sub areas, or you have your non-backbone areas, etc. So it's just that nice little separation of certain devices. Both of them also supports classless routing and VLSM. Not that it's important, but I think that's almost a given in today's day and age where everything almost does that. You do have designated routers in broadcast networks. So the name is a little bit different in ISIS. It's not called a designated router. It's called a designated or a DIS, designated integrated system. But it does the same type of function as a designated router. There just isn't any backup designated router with ISIS when it comes to broadcast networks, but more on that a little bit later. They also both support authentication, which is nice, and they both support unlimited hop count, which means a packet will stay as alive as long as the TTL will allow it. Like, the protocol isn't going to cut off the connection with something like RIP, where you have a specific like amount of hops that you can go to before the connection just stops. It doesn't do that. It's just there. You can go as long as the TTL allows you. So let's continue onwards. Now, here are the key differences. Now, this is where I actually want to get into the meat of things, because this is awesome. Firstly, the operation mode. ISIS actually runs over the link layer using something called CLNS, or connectionless network service, I think it's called. And what that is, it's actually something that doesn't require IP to work. So your ISIS devices can actually find each other and create neighborships without the need of IP, which is really, really cool and powerful, because IP does have some flaws as well, and OSPF runs over IP. So OSPF needs IP in order to connect, and it's specifically running on a protocol 89. Now, another key difference is we have different router areas. Now, when it comes to ISIS, a router will belong to a specific area. So the router belongs to area 1 or 2 or 3 or 10 or whatever you want to call the area. Whereas with OSPF, an interface will belong to a specific area. So this creates stuff like ASBRs and ABRs and whatnot. That's not the case with ISIS. If you're a router, you belong to area 1. And if another router belongs to another area, then you start getting into some type of level connectivity, which is what we're going to talk about now, is the area structures. Because ISIS is very straightforward and simplistic in this manner. You have what we call a level 1 or an intra-area router, which you can think of as an end system. It's basically just a router that's not connecting to any other area, but these routers will learn each other's routes and effectively map the network inside that specific area. Then you have your level 2 routers, which are your inter-area routers. Now think of these kind of as ABRs, but they're still not ABRs because a level 2 router will just talk to another level 2 router, all right? But then we have something called a level 1/2 inter and intra-area router. Now this is more or less going to be like your ABR, where this is a router that is kind of participating in two separate areas almost. It's in its own area still, but it's going to export routes and receive routes from a different area. So think of this as an edge router that's just there to talk to another area. Now, the difference with OSPF is OSPF has a backbone that all other areas, all other standard areas or non-backbone areas need to connect with. They either need to connect with directly, or they need to connect with something like a virtual link directly back into the backbone area. Now, ISIS doesn't need that. You can have as many level 2s and 1s and whatever as you want. So it's a lot more flexible to build your network. But on the downside is if you have some type of issue and you need something like a virtual link, ISIS does not support virtual links, but OSPF again does support that type of feature. Now let's talk about our network types. ISIS is very straightforward. You have broadcast or you have point-to-point. That's it. There's nothing else. Unlike OSPF, which has a lot more network types that you need to support, which means there's more type of things that you need to manage. Namely, you've got your broadcast point-to-point, then your NBMA and your point-to-multipoint network types. Now, scalability. Now, this is also pretty freaking cool. ISIS uses something, namely the type length value, which is not just for ISIS, it's something in the communication stack itself, where you can effectively tweak certain values in order to make a function work with the protocol. So with ISIS, you can run IPv4 and IPv6 on the same process. It runs on ISIS. You don't need stuff like ISIS v2 and ISIS v3. It's just ISIS. So everything just works with it. And we've got IPv4 and 6 and even other protocols and network types that you can use with it. Things that you probably won't use, but the options are there. Whereas OSPF, everything is a fixed structure because it was built to support IP. Now this means, like I just said, OSPF, you have OSPF v2 and OSPF, or just OSPF and OSPF v3 for your IPv6 support or your network. But these are two separate processes that you need to run. So you're already increasing your CPU overhead, you're already adding complexity to the network, just making things a little bit more difficult to actually manage everything. Now, the route learning, it's also the same but different because unlike OSPF, ISIS uses something called a link state PDU, or we can just call them LSPs for short, which is going to be flooded across the network to basically build this topology and map about everything. So I want you to think of an LSP as an LSA, although there's just an LSP, that's it. There's no LSA 1, 2, 3, 4 type, whatever. There's no external 1, external 2 types. None of that is there. So it's a lot more simple and straightforward when it comes to figuring out what's happening with the network, because we just have LSPs running within a specific area or between level 1 and level 2 routers and level 1/2 routers. But learning the messages, I think there's 4 different types of messages, but that's it. You don't need to get all complex, because I know a lot of people start freaking out when they need to learn stuff like the LSAs with OSPF, and it's really so much simpler with ISIS. We've also got some security factors. Now, since ISIS does run on the link layer, that already means it has less attack vectors, and there's also strong anti-attack capabilities specifically designed for layer 2. Whereas OSPF, obviously it runs on IP, and it makes it vulnerable to stuff like spoofing and DOS attacks and whatnot. It's also worth noting that with ISIS, you can authenticate certain packets or parts of ISIS. So you don't need to authenticate everything, or you can authenticate specific things. But OSPF is you either authenticate or you don't. So it's also like a blanket approach to everything. Now, some more differences. Our cost calculation is actually quite tricky because ISIS makes use of a wide and narrow type when it comes to routing decisions, and you can't use both of them together. Let's say the math behind it is also a little bit more complex than OSPF because it takes the bandwidth reference, it divides it by the link bandwidth, and then it times it by the narrow or the width or whatnot. And it's a little bit more complicated, I won't lie. So the cost calculation is a little bit harder to do than with OSPF, because OSPF is really straightforward when it comes to cost. It usually has a default formula that it just follows. You just tweak the reference bandwidth, and it just does reference bandwidth divided by interface bandwidth. Like that's typically what it is when it comes to OSPF. So it's nice that the cost calculation is so easy on OSPF. Then we've got our convergence. I had to do a little bit of reading about this because with ISIS, the topology and route information is separated. So if any change occurs in the area, there's a very specific algorithm that is run that then just basically takes care of that part of the map that changed, and then that is a little bit quicker than what OSPF does. OSPF is still fast when it comes to convergence. It's just ISIS is a little bit quicker. OSPF uses the network addresses as well to build the topology, and uses the ISPF algorithm when a change occurs. So it's still fast. Don't get me wrong, OSPF isn't like bad for reconvergence. It's just ISIS is a little bit quicker. So that's always nice for a big carrier network. And now 2 more points, although the last point I kind of stuck in here at the end, even though I feel like I should have put it at the beginning. But let's just cover the popularity first, because ISIS is definitely more used with big ISPs, big cloud providers, content delivery networks, stuff like that. Some like organizations that might have hundreds or thousands of routers and they need to learn different types of routes. That's typically where you will see ISIS. And it's definitely, even though a lot of people in the industry that works in ISPs like, yes, we use ISIS, there's a lot fewer people that use ISIS as opposed to OSPF, because OSPF is definitely more well known. It's definitely used a lot more often, especially when it comes to the enterprise space or small enterprises or companies or whatnot, where you don't need a big protocol like ISIS to just do everything. OSPF works fine in those solutions, and I want to let you know that you can use both protocols together as well. You could put OSPF on your edges, and then you can just redistribute those routes via ISIS in your backbone. That should work fine. People do that as well. But in popularity sense, OSPF is more popular. It's more widely known. There's more reference cases, meaning if you ever run into issues, if you just Google, hey, I have this issue, you're more likely to find something to help you, as opposed to with ISIS, you might get a lot of weird and different results if you ever search for some type of specific issue. And then the last point I wanted to make, like I said, I wanted to actually put this at the front, is the identification, because I feel this is worth mentioning that it does work different to OSPF, because OSPF you typically set stuff like a instance and you put in your area ID in there, and then you'll use stuff like your router ID as an identifier for that specific area. ISIS is different. As I said, it's all just one router, one area. So you get something that we call a net. And within that net field, you will put stuff like the area information at the very front. And then in the middle, you'll put stuff like the system ID, which it's hexadecimal, by the way. So you can either put in the loopback address of your router in there, or you could put in a MAC address of the router, and that would be acceptable as a system ID. And then the end part is always going to be the same. It's a selector bit, which is just 00. And then that is going to be what the routers actually use to talk and chat to each other, just to say who they are and what area they belong in. All right, so let's take a closer look at ISIS. Just a small diagram that I created to basically talk about the different levels that we get, because as I mentioned, we have areas. So there's area 1, 2, 3, or 1, 1, 1, 1, 2, 2, 2, 2, 3, 3. It could also be 0, 0, 0, 1 to be area 1, but this is just an example again. Now each of these areas, as we can see, they have these routers on the edges, which are either an L2 router, which would just be a backbone router. This is just a device that is there to learn or talk with other L2 routers. Or we have this L1 router at the far edges within these other areas at the bottom, so area 2 and area 3. And these are just end systems. They're just routers that's inside that area. They don't talk to another area, so we can just mark them as a level 1 router. And then we have the level 1/level 2 routers. Now their job again is kind of just like what an ABR used to do. They would be sitting at the end, and then they can talk to the different areas, but they will also let L1 know how to get to specific, or let R4 know how to get to a destination that might be in area 3, or vice versa. It could let the devices in area 3 know about the stuff in area 2, etc. It just kind of does that. It's just like this easy to understand map of how everything's connected. So what I would actually like to do is configure this with you guys so you can see how it works, how easy it is, and how cool this is. I'm going to switch to a lab in EVE-NG quickly on my VM so that you guys can just quickly see how everything flows together. So let's do that now. Alright, so I am going to log on to my EVE topology now. I've actually imported a couple of VyOS routers because they're amazing for routing and firewalling, and there's a ton of awesome protocols like ISIS we can lab with it, which I'm going to do now. So let's open that up, and then from here it's going to be a very basic setup. This isn't supposed to emulate us configuring a big carrier grade network. This is just to actually show you the different level routers, their functions, and how to get everything just up and running so that you can see how awesome and cool and easy ISIS actually is. So first thing I want to do is just log on to, let's log on maybe into this P2 router. And then from P2, what I may do is I'm just going to log on with VyOS. I'm going to head into the configuration mode. And then from here, there's 3 very important steps when it comes to ISIS. First thing being the network entity. That's going to basically tell the ISIS system which area it belongs to, as well as what this router's system identity is, what you can think of as the router ID. So let's do that by doing a set protocol ISIS net. And now if I tab this, we can see what it kind of wants a network entity to look like. So I'm going to type in 49, and you could make that 11 or 22 or whatnot, but 49 is just the default most people use. And if you search up ISIS, you'll see it's used a lot for private addressing. So we're just going to stick with that for now. So we'll make it 49. We're going to put in a dot, and now after this dot, the next 4 characters is actually going to decide what area this is in. So here I'm going to put in 000.1 because this is in area 1. And then the next step, I actually need to specify our system identity. Now this is actually going to be 12 characters, and it is hexadecimal. So if I put a dot, it can either be a MAC address or it could be an IP address. So what I'm going to do is I'm going to make this whatever the loopback address is of P2. And these are blank routers. I haven't actually added any loopback addresses yet, but this is just for our topology and our sake to understand this a bit better. So I might make this 1920 since it's 4 characters, then 0000.0002. I think I made that. So that is going to be our network or system address or system identifier. And then if I put another dot, I'll always put 2 zeros at the end, and this is just a selector. It's pretty baseline, but this is what a network entity will look like. And again, just to reiterate, these first 6 characters is basically just noting that what area you're going to be in. Then our next 12 characters specifies our system identity. And then the last important bit is the selectors, which is always 00. We hit enter, presto, we've done one big part of the configuration already. Next part is going to be adding our interfaces that we want to participate in ISIS. So I'll do a set protocol ISIS. And now my interfaces is going to be Ether1 and Ether2 for P2. So that's going to be ETH1 and ETH2. And now lastly, I want to set the level. So let's do a set protocol ISIS level. And if I tab this, again, a level 1 device is a station router or a router that doesn't need to talk to another area. Then our level 1/2 is going to be a station/area router. So it still communicates within our area, but it also talks to other areas. So think of this as an ABR. And then lastly, we have our level 2 router, which just acts as an area router. So this is just for between two different areas. So this you could probably see a lot in the backbone. But let's just set the ISIS level for this as level 1 and 2. So I'll make this level 1 and 2. I'll hit enter. And while I'm here, let's also just give this a name. Set system hostname or set system hostname P2. And let's also just add the IP addresses that I defined on my diagram here. So 10.100.1, I'll make it 11/30 for P2. And then 10.00, okay, .1/30. So let's quickly add that. So I'll do a set interface Ethernet ETH1. And that is going to PE1. And that's going to be an address. So that was 10.100.1/30. Let's just double check 10.100.1/30. That's fine. And then also my ETH2, I've added the address as 10.00.1/30. And I just want to compare my changes quickly just to make sure what I've added. And again, this is why VyOS is so nice. We can see exactly what we've done. And I can just commit this. And I can save my change, and now I'm done on the one router. So I've configured one level 1/2 router. Let's quickly configure a level 1 router, which will be this PE1, still in area 1. And this I'm just going to run by a bit quicker because I'm not going to explain all of the configuration again. So I'm just going to go into the config mode. Let's just set our ISIS, our network is going to be 49.0.0.1.1.9.2.0. 0.0.0.0.1. We're going to set our interfaces, and that is going to be ETH0. We're going to set our level, so protocol ISIS level, and this is going to be a level 1 router in this instance. We're going to set our hostname quickly, system hostname PE1, and let's do a set interface Ethernet ETH0, and this address is going to be 10.100.1.2/30. And let's compare. Configs look good, so I'm just going to commit this. I'll save. If I exit out and I do a ping, I should be able to ping 10.100.1.1. Great. And I want to show you guys something. If I do a show ISIS and I look at maybe the neighbors, let's see. I can see I have learned a neighbor. It tells me what the level is of that neighbor, what the state is, hold timers, all that wonderful stuff. But let's see if I do an ISIS route. I can see this prefix is in the ISIS routing table. If I do an IP route print, or show IP route, sorry, I'm thinking microsig here, show IP route, we can actually see what type of routes is going to be learned over ISIS, which is really cool because I'm learning the 10.0.0./30 subnet, which is actually sitting behind the P2 router. So I can see that subnet, and in theory I should be able to ping 10.0.0.1 at least, which is going to be the P2 router. Yes. So awesome. We were learning routes on ISIS. It's distributing routes for us. So this is now just communication between an L1 and an L1/2 router. Let's actually bring in another L1/2 router in a different area so we can have a little bit more communication happening. So let's log on to this P3 router. And this is going to be, again, I'm going to shoot through it quickly. So it's going to be VyOS. We're just going to head into configure mode. Let's do a set protocol ISIS network 49.0.192.0.0.0.0.0.0.0.0.0.0.0.0.0. We're going to set our ISIS interfaces, and that is going to be, just confirm here, ETH1 and 2, ETH1, ETH2. And we're going to set our level, set protocol ISIS level, and this is going to be a level 1/2 again. And then we can do a set system host name. This is P3, and let's add our IP addresses so that those IPs also just get like distributed across the network quickly. So I'm going to do a set interface Ethernet ETH1. And this address is going to be 10.0.0.2/30. And then my ETH2 is going to be 10.200.1.1. 10.200.1.1. Let's compare. And my config looks good. We can see I've added the IS details here. You can see the host name, and we can see the interface IPs we added. So let's just commit and save this. And if I do an show IP route, what are we going to get? Or I need to exit config mode, sorry. So let's just show IP route. I don't see any routes yet. Let's do a show ISIS neighbor. I do see that I have a neighbor on ETH1 as L2. So in theory, that looks fine, but we'll get to that now. Let's just quickly finish off the PE2 setup for ISIS. So all I'm going to do is log in VyOS. We're going to go into config mode. We're going to do a set protocol ISIS net 49.0.0.2 192.0.0.0.0.0.4.0. Going to set our interfaces as ETH0, I think, but let's just make 100% sure that is correct. I'm going to set our protocol ISIS level. This is going to be a level 1 router. And then we're going to also just set our other details. So set system host name. This is going to be PE2. Set interface Ethernet ETH0, and this address is going to be 10.100.2.2. Oh, sorry, it's 10.200 1.2/30. Let's quickly do a compare. Let's do a commit, and let's just quickly see, can I ping 10.200 1.1? That I can ping. And if I do a show IP route, let me exit show IP route. I'm not actually seeing the ISIS details here, which is interesting. So let's just do a show ISIS neighbor. Show ISIS topology. So here we can see what type of stuff we are learning as well. Let's do a show ISIS route. So I'm definitely learning some routes over ISIS. There I can see the 10.0.0. Let's see if I can ping out, actually ping 10.0.0.2. Let's check the routing table again. All right, so we are learning routes. And here we can actually see that we are learning a default route as well from our ISIS neighbor. So what's important to note is, since we're learning this default route, it means that even though we don't see the route on this PE2, specifically for the, like, let's say the range that exists at PE1, it doesn't mean that it doesn't know how to get there. It just means that it is following its default route to its neighbor, to its L2 router, and then that L2 router most likely knows how to get to that PE. So let's quickly see if that's the case. If I log on to the P3, I think I should still have that open. If I do a show IP route on this device, we can actually see that I do learn 10.100.1.0/30 via its neighbor, which is the other L1/L2 router. So in theory, if I go back to the PE2 and I do a ping to something like 10.100.1.1, I'm getting a response. And I can ping 10.100.1.2, which is actually the address of PE1, which is on the opposite end of the network, but I can get there. It's just that it's following a default route to get to the P3, and then P3 is actually receiving the routes from the other area, and then it just passes it on. Now, this is a very simplified way of just quickly how to configure ISIS. There is obviously a lot more details that can go into this. You can obviously add stuff like route maps and redistribute your routes. What I want to do is just quickly show you guys how insane the protocol is, because if we look at the config mode again and I do something like a set protocol ISIS and we tab that, we can see there's crazy stuff here. There's stuff like segment routing that we can use. We can do traffic engineering with it, which is actually a big part of why a lot of ISPs love using ISIS. It's really such a robust and awesome protocol. And there you can see there's the additional authentication we can add. We can put on a dynamic host name, redistribute all route maps. Route maps I would definitely recommend using just to advertise specific routes or drop whatever routes you don't want to actually receive. Just some cool bits. Now, again, it's just the baseline. I hope this has at least given you some insight to how fast ISIS is and how it can quickly learn routes across the network. But it's really a protocol that I think everybody should learn about, especially if you're working in the ISP field and you do aim to become something like a core network engineer or a network development engineer or whatever it is. You should really look into this protocol and learn it, because I can definitely say this is going to be something that a lot of the bigger companies are going to be using, and you should definitely know about it. And I feel bad about it because you could be somebody in my position where you just never had the chance to work with it, and then you've just been working with OSPF the whole time, and now you discover it and it's awesome. It is amazing, but it is something that you should have actually known about. And this is kind of why I really hope that somebody at MikroTik watches this video and they're like, hey, this ISIS thing actually makes a lot of sense. Maybe we should add it on our stack as well. Because if somebody at MikroTik's listening, guys, really, this is such a powerful protocol, and I can see so many people wanting this protocol. They're actually wanting to move over to MikroTik, switching vendors. They want to switch vendors, but their current vendors and their current backbone uses ISIS, but they cannot move to you because you don't do ISIS. So now you see I'm making videos on stuff like VyOS, and I love VyOS, don't get me wrong. I'm not going to say VyOS is bad in any way, but my channel is 80% MikroTik, and I cannot see, like, I can't understand why ISIS never made it to MikroTik. It would really be such an awesome game changer if you guys brought it over. Anyways, I'm going to end off the video here. I'd like to thank you all for watching. I'd like to thank my YouTube and Patreon members that help support the channel, and I'll catch you guys in the next video. See you soon.